Hello, and welcome to another one of my recordings. Through this recording, I'm going to cover some of the concepts in Chapter 11 of your textbook. By the way, we should have a posting telling you about the chapters, well, actually sections within these chapters to skip when you're studying for your final exam. There's a whole bunch of lots of material covered in the book, and some of it is a little bit more advanced. So we'll be telling you which sections we'll be skipping. Chapter 11 essentially discusses the concept of inheritance and polymorphism. And really, we're going to concentrate on the concept of inheritance, which is also covered in the homework assignment. Essentially, inheritance means what it really means in real life. You have a parent and maybe a few children who inherit attributes and characteristics of the parent. So consider, for example, you have a class, let's say class of all humans, and this will be referred to as superclass. And then assuming that, well, or knowing that employees and students are humans, you could create the class employee and the class of student, which are referred to as subclasses, and have them inherit all the attributes and characteristics of this class. And in addition to having their own attributes and characteristics. This way, you're essentially taking advantage of object-oriented programming features that allows for reuse of existing code. So it kind of makes programming life a little bit simpler. So for example, suppose you define classes to model circles, rectangles, and triangles. Well, we know these are all geometric objects, and they all have some things in common. For example, the date they're created or the color of these objects. And then a circle will have a radius, so that's its own attribute. A rectangle would have its own height or length and width. A triangle will have values for sides. So we create a superclass, a class of geometric objects, and then our subclasses will be circles and rectangles and triangles, and in turn we create objects of circles, rectangles, and triangles. So we'll define as many objects as we need to. So here's an example. These files will be essentially given to you through that recordings page. But let's just go ahead and look at these examples. I'm going to kind of walk through some of this stuff, hoping that just walking through them makes a little bit more sense. So notice I have import java.util.date. Again, that's just an import statement. And here I have an example where we created this variable date created to be a java.util.date. Well, if you import this thing, then you can just say date created, because date happens to be a class in this package. By the way, packages will be covered in CIT 230. So let's take a look at this, a class called Simple Geometric Object. Again, nothing different about this class, but we could treat it as a superclass. You'll notice that it has a variable called color, or an attribute called filled, and color is assigned to white. By default, booleans are always defaulted to false, and date created is essentially an object of the date type and doesn't have a value yet. Okay, as you know already, the name of the class is Simple Geometric Object. The name of the constructor is the name of the same as the class. So it looks like this has a constructor that essentially creates a new date object. So date created would be new. Again, remember, since I have this, I could just go ahead and just get rid of that. And so just say new date, and it will still compile and run just the same way. Now, you also notice that with this class, we defined another constructor. By the way, as a rule, as a matter of convention, you should always have a default constructor without any or no arg constructor without any parameters, so that we're always covered in case we use inheritance. Okay, again, what I'm covering here is no different than what we've talked about up to, say, chapter 10. It's the same kind of process. Here's the name of a constructor. It accepts two parameters. Now notice again, we're hiding color and field, or we're shadowing color and field because they have the same name as your attributes. And this is where we have to use this keyword, which I covered in chapter 10, or it was covered in chapter 10, because I can't say color equals color, because then we don't know which object does this variable go with. So this color, this will go with the object that called was created from this class. Get color returns the color. That's the same as before. Set color accepts color and accepts it again. You need the word this. Again, remember, if you change this to any other variable like C, then you could just say color equals C. Is field, return the field, parameter, and set field, sets it. This returns the date created. Again, I can just call this date. And then toString. Now, we talked about toString back in chapter 8, I believe. Every method essentially has a toString, not every method, every class could have a toString method, which allows you to be more creative when you display the value stored in an object. So this toString is actually returning some text followed by some variables. And without this toString, if you decide to display the name of the object in a print statement, you're just going to get the name of the object followed by some memory address location, which is going to be useless. Now, this is the superclass. Now, let's take a look at the circle from geometric. Notice you have the same definition, public class circle from geometric. And here's the extends keyword, which is brand new. And the word extends essentially means inherits from simple geometric. So as soon as you add this statement, you're saying that this class inherits all the attributes and characteristics of this class. That's all. And notice it has a variable of its own. Radius is its own variable. So not only does it have a variable named radius, it also has a variable named color, field, and date created. Notice I don't have to redo any of these because this class is inheriting all those attributes from the parent class. Now notice you still code the constructor with nothing. It just happens that we don't do anything in there. But you can add more code if you like. Notice this constructor accepts the radius and sets the radius. Now remember, radius only belongs to this class. This parent class doesn't even have a thing called radius, and it shouldn't because rectangles don't have radiuses. So we shouldn't put anything that doesn't belong to a generic geometric object in here at all. All right, so let's go back again. So now notice here you've got your constructor, accepts a radius, accepts a color, accept field. This dot radius equals radius. This is the parameter right there, or the attribute right there. Now you see the function call or the method called set color. So where is set color? Well, if I look inside this definition, obviously it's not here. So because it extends this, what Java is going to do is going to look at the parent class and see if it has a set color method. And sure enough, there is one. So we're actually reducing a lot of redundancy by not having the set color and set field here. Now get radius returns the radius, set radius sets the radius, those are standard. Get area just multiplies the radius times pi, that's just the area of a circle. Get diameter, twice the radius, 2 times radius. Perimeter, 2 times radius times pi. Again, these are just some basic geometric calculations for a circle. Now notice we have a function or a method called print circle. It calls get created. Well, get date created is a method. Where is this definition? It's not in here, so it must be here. And sure enough, it's right there. Now again, of course, if you misspell any one of these, when I compile this thing, it's not going to find it, and it's going to give you an error message. All right. Now, what I just went over is no different than what you're going to find in this rectangle class. Notice it's the same idea, except now you have height and width and height. I guess I should have called it length and width. Same exact idea. Set the colors, set fill, and get width, get height. These are all pretty simple to follow. Now let's look at a main or test class, which essentially allows us to create objects from our classes and exercise the various methods in there. So circle from simple geometric object, that's just the name of a class that must already exist. The name of the object is circle, is equal to new circle from simple geometric object with 1. So obviously you're going to construct an object named circle, calling the constructor circle from simple geometric. So let's go and look for that. And sure enough, here's the constructor. It accepts one parameter, and that's why you're calling this one. Remember, I already also have this constructor, but I'm not calling this because I'm only passing one parameter, and Java at runtime will know which one to call because you are passing only one value versus 3 values. All right, so it's going to go in here, and it's going to set the radius to the radius. So the radius of circle will now equal to 1. Now here's one distinct difference, and your book, I believe, does a good job of explaining, is that in case of inheritance, what Java does, it will automatically call the constructor of the superclass. Now the reason it does that, the reason it calls the constructor of the superclass, is so that Java wants to make sure that everything is properly initialized. So even though you don't see this right there, or actually right here, right before the statement, there is actually a call to the superclass so that we go to here and we assign a date created. So that's how the date created variable is initialized for this parameter or for this object. Now, of course, you also, because you're going here, you also set the color to white and you set the fill to false. So all of that happens just by this object creation. Now, let's see what happens here. You say system.out.println a circle followed by circle.toString. So what is Java going to do? Well, it's going to go looking for a object named circle. So it's going to find the class that the circle belongs to. So it's going to go here and it's going to look for a method named toString. I'm going to put it there. So go look for toString, and I don't see it. So looks like it's not here. So then we must be calling the parent toString, which is right there. So remember, this one already set a circle. We go here, oops, right there, and it says created on. Date created, we already know when it was created. We already know the color was white, and we know the field was false. So it goes to toString, comes back, and goes and runs this line. So the next one says the color is circle.getColor. Go in here. Are you going to find getColor here? Obviously not, because getColor is in the parent class, and the parent class just says give me a color. So that's it. That's all it's going to do. So if I run this thing and I compile it, and then it's taking a little bit longer, and then I'm going to run this thing. Notice it says right there a circle created on this date. Remember, this was a circle. ToString was responsible for created on, and then this was the date, which one get date. So it's April 28, 1714. That's when I run this code. Next one is the get color, so it's white. radius is 1, and the area was calculated, and so on. So hopefully you can satisfy your curiosity, I guess, to see, to go in here and double check and make sure you know how this rectangle object works. It works exactly the same way. So what did we gain? We create the common attributes right there, and then we created this other classes with their own attributes and their own characteristics. Okay, so let's go back to the slides. I'm just going to kind of go in here and kind of tell you, this is what I was referring to, is that if you have public A, which this is your class A, this is inherently your Java is actually calling this method using this super keyword. So, I mean, I could have just gone to my file here, and right there, remember I said there's implicitly a call. I could just do super like that. And this program will do exactly what the other one did. It's no different than anything else. So if I ran this thing, I should get the exact same answer as before. But it's not needed. But is it good to have? I suppose yes, because now you're showing that you're implicitly calling the constructor of the parent class. I'll go ahead and erase it there. Okay. Next, I'm going to go to, so that's what this is all about. Using the keyword super, so we call the superclasses constructor. We can also use super to call a superclasses method. Now, remember, this class or rectangle class, these things have their own methods. Now, if you ever wanted to call a method from, let's say here, set color, I could have just said super dot set color, even though that's implicitly defined that that's what I'm calling because set color doesn't exist. But by doing this, I'm actually making the program a little bit more conventional, more usable, even though it's not needed. That's what, as long as you understand that that's what's happening, you don't need that. But those are the two uses of the super. Either call a method in a superclass or use it to call the constructor. Remember from back in chapter 8, we cannot implicitly call the constructor. So that's why we have to have the super, but again, remember by default, if you don't have one, Java will still call it for you because Java wants to make sure that everything is initialized properly. Okay, let's go through some of these. Okay, I guess you can read that's on that. Oh, this is a good slide. This is I want to leave this up to you. This is slide number 9. It kind of walks you through the process of what really implicitly happens when you have chaining or when you have essentially classes that are extending or inheriting from other classes. This example, by the way, looks something like this, where you have faculty extends from an employee, and employee extends from a person. So you know that if you define an object from faculty, you're going to be calling the constructor here, and here you're going to call the constructor there. Again, remember the whole idea is so that Java is making sure that everything is properly initialized. So let's go through this. I'm just going to walk through it. I'm just going to press the enter key, and they're just going to walk you through it. This is where we start. Here we say new faculty, so obviously we're calling we're creating an object, calling the constructor and faculty. So I'm in here. Now remember, faculty extends employee. So when I press enter, it doesn't actually display this. It's going to go to the employee because the employee extends a person. It's going to go here looking for that employee constructor. Then it sees a call to this with a string. So it's going to look for the employee with a string. So it's going to call that. And then because employee extended from a person, it's going to go in and call the constructor in person. So it invokes the person constructor. And then it's That's the person constructors are there. So the very first output statement from this program is going to be this. Persons no arc constructor is invoked. And then it's just going to go backtrack from where it left off. It's going to execute this. Obviously, it's going to execute this. It's going to execute that. And then it's done. So it's kind of, um, um, I guess it's kind of, it's not very intuitive in the set because of these implicit calls. And remember, the only reason we're doing these weird behaviors because of the extends keyword, because of the properties of inheritance. So here's a good example. You have public class apple. Well, apple inherits a fruit, so I guess you can create another class called orange, or uh, create different classes for different types of fruits. And then class fruit, which is which is this, has a constructor that accepts a name. It doesn't have a no constructor, so you will get an error message because you need one. Otherwise, if there is none, you get an error from Java. So that's why it's always a good idea to define constructors in superclasses and obviously in your subclasses. So a subclass inherits from a superclass. Now you can add new properties, which we saw. Radius was a good example. Add new methods. Well, get radius, set radius will be good. And we can override the methods of the superclass. Now, we already talked about the concept of overloading. Overloading was when you had one method with the same, or more than one method with the same name, but different parameters. So we could have a method named total that accepts 2 parameters, and a method named total again with 3 parameters. And when we call it, Java will know which one to execute based on the number of parameters. That's called overloading. Overriding is really goes with the concept of classes and inheritance, in the sense that the name of the methods must be the same that you override, and the parameters must also be the same. So that's really the difference between override and overload. And essentially, what you're thinking about is that, well, I have um, a method, let's say here, called print circle, and in it, I'm calling get date created. Well, I could call that using the super to call the superclass. Now, if I wanted to have my own get date created, I could put it in the circle class. That way, essentially, instead of going to the superclasses method, I'll execute the subclasses method. So overriding methods, a good example again is toString, which you could override. So I guess there's a good time to go back to our example. I'm just going to copy this here from here and Control C. I'm going to go to my class circle. So class circle right there. And you'll notice class circle has a print circle that just prints it. But can I add my own toString? Well, the idea is, well, why not? And did I grab everything from? Yeah, I did. So this toString here is going to override the toString here. So when I call the or an object with a toString, it's going to go in here instead of going to this one. And you can let's see how this works. I'm just going to put some asterisks here so you can kind of see. So again, I just created my own toString method. So I'm going to compile this. And then I'm going to go in here and let's just, well, I can just run it. Notice how when I first ran this thing, I didn't have all these asterisks, the radius is 1, because I didn't have this whole method. But if I didn't have this, I must have had something to display this one, right? So essentially, instead of calling this, me go back in here. So I'm also, let's see here, a circle created on, okay, let's just walk through this. I'm going to leave this over here. And remember, the only thing I added was my own overriding, to override it to string method. So when I went in here and I created my circle object, just like before, it went over here to circle. It went in here. Remember, I called the constructor, created the date, made these white, and filled was false. So that's what that was all about. And then I says a circle plus circle.toString. So now we're going to go to circle.toString, and I'm going to go here. Now remember, this one says super.toString, so I'm going to go here and say created on, date created filled. That's why you have all of this stuff. Then it's going to come back to plus. I had all my asterisks. I just put this there so that you could see what's happening. And then the word radius is 1. Okay, so essentially this is what we mean by overriding. Even though I have a method named toString here, I can add my own stuff to toString after I call the parents toString. Again, sometimes you may want to be able to do stuff like that, where not only do you display what the parent displays or does, you also add your own functionality to it. So that's just that's what we mean by overriding. Again, any method in here can be overridden by this. Now remember, the rule is for overriding, the names have to be the same to a string, and the parameters have to be the same, and the return type has to be the same. If it's not, overriding will fail, and you won't even run it, or you won't even execute it. Now, one thing I want to show you here is, let me just go ahead and compile this. And again, this is the same program. Let me close these. And I'm just going to misspell. Well, you saw that this worked just fine. I'm going to misspell this. Okay? I'm just going to say 2, I don't know, 1, 2. Okay, S12, or maybe misspell S with a lowercase. Doesn't matter. I'm going to compile it. And it's going to compile without a problem. And I'm going to go back and I'm going to run it. Now, one thing you notice is what happened. What happened to all that asterisk and the radius equal to 1 that was there before? It didn't happen because it didn't call the toString here, and it actually ran the toString in the parent class. And that's why we want to have this in the parent, just as a insurance policy, essentially, that something will be returned to us. So if you misspell this, you won't actually execute it. But one thing that your book talks about is that if you go ahead and add a annotation like @ override, you're now telling the compiler that, hey, I have an override function here. So notice what happens when I do when I compile this, I actually get an error message saying that there is a problem. Method does not override or implement a method from a super type. That's true because the super type is named toString. Here is named toString. Well, it's actually misspelled altogether. So I'm just going to erase that and just same code, compile it. Of course, now they're okay. And then if I go back in here and run this thing, I'm going to get this call again, and I'm good to go. Okay, looks like I'm almost at the half-an-hour mark. And by the way, again, some of the things that we're going to, again, we'll make a list of what we will be skipping from the final exam. And as a matter of fact, some of the concepts, again, you're supposed to be able to scan these things and read through these slides and through the book, but some of the material will be skipped and will not be covered in your final exam. Okay, I hope this helped a little bit. Again, feel free to ask any questions about this presentation or any other thing in the discussion forum, or by sending an email message. Okay, Have a good day.